Welcome to the class, dear students. In today's lecture, I am going to explain you about tests of significance. The tests of significance, and in my couple of previous lectures, I have explained you what is meant by the test of hypothesis, what is meant by the hypothesis, and when do you say that what do you mean by the null hypothesis? What is the alternate hypothesis? How to calculate the z calculated values and all, and when you say that the hypothesis is accepted, when it will be rejected, all what is the rejected region, what do you mean by the critical region, all these I have explained in the previous lectures. In the just previous lecture, please go through that to understand all the concepts of accepting region and the acceptance region and the critical region. In today's lecture, I am going to explain you how to use the tests of significance in different scenarios. That means if the population, for testing the population mean, when the sample size is greater than or equal to 30, and when the sigma, that means the population standard deviation is given, then we use the formula to find out the z calculated value is given by what is the sample mean and what is the population mean, their difference over the standard deviation, the population standard deviation by square root of n. This gives you the z calculated value, x bar minus mu, both the means, the sample mean minus the population mean, over sigma by root n. Next is how to find out suppose if the sigma is not known, is unknown suppose, then for the test statistic, when n is less than 30, the sample size is less than 30 suppose, then we use the t-test, student's t-test we call it as, and that calculated value under the t-test is given by, again the difference between sample mean and the population mean over, in the place of sigma you will have s. That means s is what? The sample standard deviation over square root of n minus 1. Whenever sample you are considering, we are square root of n minus 1 we do. What do you mean by sample standard deviation? That is sigma xi minus x bar the whole square over n minus 1 under root. So that gives you the sample standard deviation. I hope you could understand this. And then what we do, when suppose you have let us say the test statistics for the difference in means of two large samples. Now two large samples means your sample size is greater than or equal to 30 and they are having the common standard deviation. Both large samples are having common standard deviation, let us say sigma suppose. Now here we have compared with what? The sample mean and the population mean. Here we are comparing with the two sample means, therefore it is x1 bar minus x2 bar over, because you know the population standard deviation, so sigma into square root of 1 over n1 plus 1 over n2. What are these n1 and n2s? n1 is the sample size of the first. There are two large samples, correct? So n1 is for the first sample, n2 is the second sample size. Next is, suppose if your sigma is unknown, the population standard deviation is unknown, and you have the two samples and their standard deviations are known. Then what we see, we take the x1 bar minus x2 bar of course, and then what we do, we take the standard deviations of both the samples. Like in the place of sigma, you are having x1 square by n1 plus s2 square by n2 under root. So this gives you the test statistic of to find a difference between the two small samples. If it is this one, the two samples, where the two large samples, common standard deviation is this. And this is for sigma and the mean of the sample mean and the population mean difference over the standard deviation over square root of n minus 1. So all these we will, I'm sorry, here we have to write, my dear, this is square root of n minus 1. This is, yeah, xi minus x bar the whole square by n minus 1 under root, correct? This is what the sample standard deviation. So you let us remember all this. Now let us go to the very important points to be noted even in the multiple choice questions or for any competitive exams. This type of questions may be asked. So when do you accept the null hypothesis means, if the now we will be using this problems, we will be using finding out z calculated value. Then we find out the corresponding z table value. Then if this calculated value happen to be less than the table value, then we accept the null hypothesis. Okay, otherwise we reject the null hypothesis. While doing the problems you will understand more about this. And then if you remember these table values, actually it will take less time. At the time of examination you won't feel to be the time is running or something, because at the z alpha, when two-tailed test, suppose at 0.10 confidence, that means alpha equal to 0.1, that means that this is what the rejected this one. So when alpha is 0.1, what is the confidence level? It is 99% confidence level it is, suppose, then it is 1.65. And when it is suppose 95% confidence, that means alpha is 0.05, then it is 1.96. And you have suppose alpha is 0.01, that means 1% is the critical region. 1% means it is 90, 1% means it is 99%, which is 2.58. Okay, so this is 10%, that is for 90% confidence it is 1.65, 95% confidence it is 1.96, and 99% confidence it is 2.58. These are the table values for two-tailed. And for one-tailed, when you take 0.10, then it is left tail means minus 1.28, right tail means 1.28. Alpha is 0.05, and this is minus 1.65 and 1.65. When alpha is 0.01, it is minus 2.33 and 2.33. If you want to understand one more thing, here you can even rewrite what is this. Alpha is 0.10 means 10% confidence. 10% confidence, 10% critical means 90% confidence. Okay, and this is 95%. And this is 99% confidence level. I can write here it is confidence level. Okay, so then you can understand very clearly. Suppose in the problem 90% confidence level is given, you can write 1.65, 95 means 96, 1 point, and 99% means 2.58. So remember like that. Let us now start the problems. Now here the question given in this problem is, a researcher wishes to claim that the mean number of days that a basic model of automobile sight on a dealer lot is greater than 29 days. So now a sample of 30 automobile dealers. So what do you mean by 30 automobile dealers? As soon as you see, whenever it is the sample size is n is greater than or equal to 30, it is the large sample, and z statistic we use. So first thing is n, and we have identified what is n here. Let us now solve this problem. First, n is equal to 30. So it is large sample. First thing you have to understand that. And then what was given? It has a mean of 30.1 days. And what is the lot is greater than 29 days. So what is the mu here? Basic model automobile sight on dealer's lot is greater than 29 days. So what is population mean is 29 days. And what is your X bar here? The automobile dealers has a sample of 30 automobile dealers has a mean. So what is the sample mean X bar is given as 30.1. And the standard deviation of the population, that means the sigma is known, which is 3.8. Now at alpha is equal to 0.05. So alpha equal to 0.05 means What is that? It is 95% confidence level. When it is 95% confidence level, then what is its Z alpha value? We have just now done that. When 95% confidence level means, I told to memorize this like 1.96, that is Z alpha. This is what the tabulated value. Okay, this you can memorize. And now let us consider this one. But here, what was the question asked? At alpha equal to 0, is there any evidence to reject the claim? And the mean of days that a basic model site on dealer's lot is greater than 29 days. Is very much clear that it is greater than. What do you mean by greater than? It is very much clear that it is what is the null hypothesis? First of all, we will write down. What is the null hypothesis is mu is equal to 29. And what is the H naught? Okay. What is H1 is the alternate hypothesis. In the alternate hypothesis, we have to write it as mu is not equal to 29. But here try to read the question. Dealer's lot is greater than 29 days is given. So it is not equal to, it is greater than 29 days. Is it one-tailed or two-tailed now? It is one-tailed, since it is given as it is greater than 29. Now, because you people generally when you do the problem, this is what we write, right? So what we do now is we write this Z alpha as 1.65 is what? Two-tailed. But Z alpha 0.10 and greater than, right? So it is 0.05 means it is 1.65. So this is what you have to take as the Z alpha. I purposely wrote this as Z alpha is this. You will be doing the same mistake actually. So I don't want you people to do the mistake in the exam. So when you see the that is greater than, first of all, to write down Z alpha tabulated value, you have to see whether it is two-tailed or one-tailed. If it is two-tailed, then it is 1.96. If it is one-tailed at 95% confidence, it is 1.65. So it is very much clear now. So let us now calculate Z calculated value. What is this given by? It is x bar minus mu over sigma by square root of n. What is x bar here? It is 30.1. And what is mu here? 29. And what is sigma? 3.8. And what is square root of n? N is what here? 30. So all these values we will be finding out and do the calculation, and this value is giving you 1.5855. So now what is Z calculated value is 1.5855 and Z tabulated value is 1.65. This is table value, this is Z calculated value. So what is Z calculated value is more or Z table value is more? Calculated value is more. So Z calculated value is less than Z table value. Therefore, we accept the null hypothesis. Accept the null hypothesis H naught. What do you mean by this? That means at alpha, is there any evidence to reject the claim? No. We are accepting the claim. Is that clear? So we accept the claim, that we accept the null hypothesis. I hope it is clear to all of you. So this is what the way of understanding the problem, and please make sure that this whole thing when you are writing, first thing you have to understand whether it is small sample or the large sample. That is the first step. After finding out the large sample or the small sample, you will be finding out what are all these inputs, and what is given as 0.05 means 95% confidence level, and you have to write down the Z alpha value. But before writing Z alpha value, you have to confirm whether it is two-tail or one-tail. Since it is asked very clearly it is greater than 29 days, it is very clearly it is one-tail. When it is one-tailed, what is Z alpha value at 95% confidence level? And then using this formula, you can see this value. I hope you could understand it. Thank you so much.